Hi everyone, my name is Tal, and today we're going to go over net ionic equations. Before we begin, I just wanted to mention that you should already have an understanding of how to balance chemical equations, and you should also have an understanding of how to use your solubility rules to determine the solubility of different ions and in order to determine their states of matter. So, our learning objectives. After this video, you should be able to define what a net ionic equation is, define spectator ions, understand the purpose of net ionic equations, and solve problems to find the net ionic equations. So, what is a net ionic equation? Well, a net ionic equation is a chemical equation that only shows the components that are directly involved in the chemical reaction. So when you get a really long chemical reaction, not all of the ions that are shown in that reaction are actually going to lead to the final product that you're looking for. They actually aren't involved at all. So we can take this out and be left with the net ionic equation. And that would just be your solid product and the aqueous ions that form that solid product. So what is a spectator ion? A spectator ion is an ion that does not take part in the chemical reaction, and they're found in both the reactants and the products. So in this equation, we have sodium chloride and silver nitrate, and that makes sodium nitrate and silver chloride, which is a solid. In this diagram that we have here, you can see all the different ions floating around, and this is before the reaction. After the reaction, you have your sodium chloride solid and your silver chloride solid, and then your sodium and nitrate ions still floating around, which indicates that they weren't actually involved in creating this silver chloride. And we can see that with there's our final equation. It just shows the chloride and the silver that makes the silver chloride solid. There's some important things that you cannot forget when doing these. You need to make sure that there are equal masses of each element on both sides of the equation, which just means you need to make sure that your equation is balanced. And you also need to make sure that the overall charge must be the same on both sides of the equation. That's really important as well. Your steps to find the net ionic equation. So first you're going to write and balance your equation, which you should be able to do already. And then you're going to determine the states of matter of each substance by using your solubility rules, which again, you should be able to do already. After, you're going to write the ionic equation by only breaking down the soluble compounds into their ions, and those are your aqueous compounds. And then you're just going to remove the spectator ions. Okay, now we're going to practice with this example. So we have our sulfuric acid and sodium hydroxide, and that makes H2O, which is a liquid, and sodium sulfate. So we're going to break down all of these compounds into their ions, and here's what that would look like. And I want you to pay attention to, so this equation was already balanced to begin with, but notice here with the sulfuric acid, you have to know the charges on each of these elements. So we know that sulfate has a 2- charge, and if you don't remember your polyatomic ions, you don't need to worry, because from the crossover rule, we know that this subscript of 2 on the hydrogen indicates that there's a 2- charge on the sulfate. So just in case you don't remember your polyatomic ions, you're good. So that's how we know how to break down the sulfate. And then we know that hydrogen just has a +1 charge, so we can just leave it like that. But where did this 2 come from? So in the original molecular equation, we can see that there's 2 hydrogens because there's a 2 subscript. So we can't just leave this hydrogen by itself, so we have to add a 2 in the front. We wouldn't add the 2 to the sulfate because we still only have 1 sulfate. So that's how we got that 2. But when you look over at sodium hydroxide, there's a 2 coefficient in the front of the whole thing. So that's why we can bring that 2 down for sodium, and we can also bring that 2 down and put it in front of the hydroxide. Then then we don't break down our H2O because that's a liquid, it's not aqueous. And then for our sodium sulfate, it's the same thing that happened over here. We know the sulfate has a 2- charge because of this 2 subscript on the sodium, so we can add that. And then the sodium has the +1 charge, but because there needs to be 2 of them, we have to add the 2 in the front. Now we can take out our spectator ions. So our spectator ions are going to be the same on the products and the reactants. So we can see that this SO4 2- is right here, and it's also the sulfate right here. So we can just cross it out. And then same with the sodium. We have 2 of them right here, and we have 2 of them right here. And now we only have 1 hydrogen, 1 hydroxide, and 1 H2O. Now we can be left with our Ionic equation. But in this case, we can actually cancel out the 2's in the front because all of them have a 2 coefficient in the front. So that will leave you with your final Ionic equation. Now we're going to do some independent practice. So here is your equation. It's already balanced for you. I want you to pause the video and then do all your work, come back and see if you get your answer right. So here is your full Ionic equation. And as you can see, we did not break up the solid because it's not aqueous. And here is your final net Ionic equation. Thank you so much for watching. I hope these types of problems are a lot easier for you to approach now, and make sure to keep practicing.